Okay, thanks for the time. Here is I'm going to share about how do I use graph algorithm to study molecules here. So there are actually several files in here, and I'm going to introduce the whole flow here, step by step. And firstly, I have my txt of two different molecules here, given that my student ID is as n as an odd number, so I have this file here. And next that I'm trying to use the visualize molecules.py here and trying to trying to fill the structure of the two different molecules that when I run after this Python script, I'll have these two molecules, the first one and the second one here. Okay. And after this, I'm gonna run this small to edge list Python, which helped me to generate the input.txt file here. And what exactly we're doing here is actually trying to convert all these two molecules to this structure to make it simpler for our analysis later if we're using the Python here. So after we have input.txt file this here, and we can go through the next step here to run the project.python .python script here. Here is what we are doing about studying the algorithm of BFS, DFS, Casco, and just Destra. Okay, so let me briefly introduce the script here. We got four different algorithms here, but BFS will helping us to search level by level, and DFS here helping us to search the depth first, and Casco here help us to find the minimum connections, and Dextra here will find the shortest path of the algorithm, the graph. Okay, so basically I just run this whole script, and there's a flow to print out the results of four algorithm analysis for that two molecules here. So I'm trying to run this right now. As you can see here, we can have two different molecule results here, including all the adjacency lists and BFS, traversal orders, and also the edge, the BFS tree edge here, DFS also as well, and also the orders for DFS. Casco as well, MST weights 13, MST edge here, we have 12 edge for molecule 1, and here. Also, we try to find the shortest path from C0 to C7 here. Okay, and I have also saved that two things, that results to here. Okay. Okay, so generally this is the whole of my flow of the project demonstration in doing programming with my algorithms for applying these four different algorithms. But actually I've also prepared a PowerPoint for this demonstration, but I think due to time limitations, I'm not going to finish all slides here, but basically I can just briefly introduce like what we did exactly of the whole project. We try to apply the four different algorithms here for the two different molecules here, and then we have also tried to compare where we have applied the BFS and DFS to our two molecules starting from C7, and then we have a Casco minimum spanning tree analysis as well, also to find out having the findings of the algorithm here. The big O E log E is actually applying to our Casco tree, and yes, here, here, and continually I have put all the comparative results and comparison figure, and also the molecule distance for on this slide. You can see the Destra algorithm, and also the findings, the results of guides that two different molecule in different summarize. Okay. And here we got the findings. After doing these two molecules analysis, we have this finding and proving that time complexity of 4 different algorithms, that just like what we've mentioned before, BFS, we have a big O, V plus E. In DFS, we have a capital O, big O, a V plus E as well. In classical, we have a big O, E log E. This trial have a big O, V plus E, and log V. Okay, and here is kind of the conclusions. What I have here, I think I can summarize that BFS is explored layer by layer and finds the ring edge, and DFS goes like depth and counting the rings like one back edge per ring. In classicals, MST shows like which bonds are necessary and which are extra, and finally the extra finding path that prefer single bonds over double bonds, like here. Yes, so yeah, just thanks for the time, and here's my proof, and here's my presentation as well. Thank you for the time.